Hey there. In the previous video, we saw about the processor, what are its functionalities, what are the different components within the processor, which is a CPU, in which we had a control unit, arithmetic logic unit, and we talked about the secondary storage and I/O, how they interact with these components, and within them we had many registers in both ALU and CU. And now specifically in this video we will talk about that portion of the CPU which we did not touch yet. So we will focus on these parts, that is the memory of the CPU. Okay, we call it main memory because we saw that a computer's CPU contains necessary circuitry for data processing and controlling other components of the computer. However, one thing it does not have is that built into it is the place to store program and data needed, okay, during the data processing. We also saw that the CPU contains several registers for storing data and instructions, but they cannot store only if they can only store few bytes at a time. They cannot store the huge data. They are just sufficient to hold only one or two instructions with corresponding data. Okay, if instructions and data of an executing program were to reside in the secondary storage like a disk, this secondary storage, and fetched and loaded one by one into the CPU registers as the program execution proceeded, this would lead to the CPU being idle most of the time. Okay, this is because there is a large speed mismatch between the rate at which the CPU can process data and at the rate at which the system can transfer data from disk to the CPU registers. There's a huge mismatch in their speeds. So to overcome this problem, there is a need to have a reasonably large storage space that can hold instructions and data of a programs on which CPU is currently working. Okay, the time to fetch and load from this storage space into CPU registers must be very small as compared to that from the disk storage to reduce the speed mismatch problem with the CPU speed. Okay, every computer has such a storage space known as this primary storage. We call it main memory, also we call it primary memory, we call it simply a memory only. So this is the functionality of this memory. So let me tell you the a little organization of this memory first of all. So main memory of a computer system consists of several small storage areas called locations or cells. Okay, let me draw it aside over here so that you can understand it in a better way. So I have made it here. I was saying that the main memory of a computer system consists of several small storage areas called locations or cells. These are the locations or these are the cells. Each of these location can store a fixed number of bits called word length of a memory, as I have mentioned it over here. Okay, so hence, a given memory is divided into n number of words, and n is generally some power of 2. Obviously, it will be the power of 2. Each word or location has a built-in and unique number assigned to it. This number is called address. Here I have mentioned it also. So the address for the particular word size is here. So this number is called address of a location and is used to identify the particular location of a memory. This is the little organization of the main memory, how main memory looks actually, and what are different components over there. So I will tell you something over here which is very frequent in our day-to-day lives. You might have heard about the 16-bit computers, 32-bit computers, 64-bit computers from your friends or family or technical expert used to say you should buy the 64-bit computer or a 32-bit computer. Actually, they refer to the memory word length. This memory word length of a small computer is somewhere around 8, 16 or 32 bits, whereas that of the large computers in nowadays is 64 bits or more. The obvious question that arises is, what is the advantage of having more numbers of bits per word? Instead of having more words of smaller size, we can do that also. But for an answer to this question, imagine a highway with 8 lanes and a heavy flow of traffic. If we expand it to the 16 lanes, traffic flow speeds up considerably. 8 bits in analogous to the number of lanes on a microchip. More bits means a more rapid flow of an electronic signals. In other words, we can say a faster computer. Hence, the amount of the data that an 8-bit computer can transfer to and from the memory in 1 minute, a 32-bit computer may transfer it in a few seconds only. This was the basic terminology of these 32-bit computers, or we can call 16-bit computers. Why are they 64-bit computers and etc. Since I have told you about the structure of the memory in the CPU and its word size, different word sizes, I want to tell you there are many types of the memory chips, those memory. So I will tell you one by one. Look, if I write memory, we might have uh, volatile one, we have a non-volatile. Okay, in volatile we have RAM, simple RAM, but there are two types of RAMs, that is static RAM and we call other as a dynamic RAM. Okay, I will tell you the difference. And in here in a ROM, in non-volatile, we have a ROM. Okay, and we have uh, user programmed ROMs. Okay, user programmed ROMs. So we call them PROMs. Okay, programmable ROM, EPROM. And in EPROM we again have two types like UV EPROM and we have EEPROM. Okay, I will tell you all of them. I will explain them to you. So memory chips are classified mainly based on their capability to retain or to store data when power is turned off or interrupted, and how easily stored data can be altered or overwritten. Okay, first let me tell you what is a random access memory, that is the RAM. When people talk about the computer memory, they usually mean the volatile RAM memory. Okay, physically, this memory consists of some integrated circuits, which we call ICs, as we saw in generations, either on the motherboard or on a small circuit board attached to the motherboard. This was the basic thing about the RAMs, and those RAMs are having the specific dedicated slots on the motherboard, which we call SIMs or DIMMs, like SIM. M means SIM, and nowadays it's a DIMM. Okay, SIM means single inline memory modules, and DIMM means dual inline memory modules. Okay, nowadays DDR4 supports DIMM. Okay, Now, read only memory, what does this mean? A special type of RAM, okay, a special type of memory, we can say, called read only memory. From the name we can guess it's only for the reading purpose, not the writing purposes. Is a non-volatile memory chip. It's a non-volatile, specifically make a note of this thing. It's a non-volatile memory chip in which a data is stored permanently, okay. Usual programs cannot alter this data. In fact, storing data permanently in this kind of memory is called burning into of data, okay. Burning in of data, because data in such a memory is stored by using a fuse links. Once we burn fuse links for some data, it's permanent. We can only read and use data stored in the ROM chips. We cannot change them. This is the reason why it is called read-only memory. As I have told you, since ROM chips are non-volatile, a ROM chip does not lose its stored data in case of power off or interruption of power, okay. This is unlike of volatile RAM chips, in which we saw that if the power is interrupted, the whole data is lost. ROMs are also known as field stores. We call them field stores, we call them permanent stores, we even call them dead stores, okay. Those are the different names of the ROMs. All right. Now there is a another thing, user programmed ROMs. PROM means programmable read only memory. That means one can program it according to its one's use. I mean, a user can program it, okay. Now, user can program it, but there is a technicality, specific technique to do it is by using electricity. That is electrical programmable read only memory. So by using electricity we can change the data into the ROMs. There are again two types, like UV ROM, that means ultraviolet erasable programmable read only memory. So by using ultraviolet rays we can erase and program the ROM once again. And here's the next one, that is this was the erasable programmable read only memory, and in here we can use the next E, which is electrically erasable programmable read only memory. That means by using electricity we can remove those ROMs. You know, the best example of EEPROM is the pen drives, okay. Pen drives are the specific easy example of EEPROMs. Those are not the disks like the secondary storage disks, okay. Those are actually the EEPROMs. Those are the ROM memories. All right. So now there is the last memory called cache memory, okay. We can see it over here. It's near to the processor, there is a specific functionality of cache memory, why it is near to the processor, and the other memory chips are little bit far. But cache memory is residing between the RAM and the processor. All right, we saw that use of the main memory helps in minimizing the disk processor speed mismatch to the large extent, because the rate of the data fetching by the CPU from main memory is about 100 times faster than that from a high-speed secondary storage disk, okay. Still, the rate at which the CPU can fetch data from the memory is about 10 times slower than the rate of which the CPU can process data. Can you imagine this thing? So performance of processors often gets limited due to this memory processor speed mismatch. All right, obviously we can improve the overall system performance greatly by minimizing the memory processor speed mismatch. Cache memory is commonly used for this purpose. It's an extremely fast small memory between the CPU and the main memory, as I have told you already. I told you this thing, that cache is residing between the CPU and the main memory, whose access time is close to the processing speed of the CPU. This is the main functionality of it. It acts as a high-speed buffer between the CPU and the main memory, and a computer system use it to store temporarily very active data and instructions during the processing. So since cache memory is faster than the main memory, system's performance improves considerably when the system makes those data and instruction available in cache that processes need during their present processing. This was about the cache memory. So what is the purpose of the cache memory? And remember one thing, there is a three layer cache memory, L1, L2 and L3. It's of few kbs, it's also of little more kbs, and it's of few mbs. Okay, 4 mbs to 6 mbs are the ideal sizes, not more than that. Only few mbs are the size of those cache memory, whereas the rams could go up to the GBs, that means 32, up to the 32 GBs, and even more for the latest generation computers. So this is the little explanation about the memory. What is the job of the memory in the CPU, how it is made, what is its specific functionality, what are the bit sizes, word length of the computer. There is a memory hierarchy which we already read, and the concept of cache memory also I gave it to you. I hope you have enjoyed this lecture and you came to know about many things about the memory as of today. After watching this lecture, I hope you would love to watch my future lectures also. So I will feel glad if you do so. So do like, share, subscribe my video, and share it with your friends so that they can come to know about the little concepts about the computer science. So till then, take care of yourself. Thank you very much.